Here we're going to take a look at combinations, which oftentimes are put together with permutations to form, kind of a broader topic here. Because in both situations, we are taking some collection of distinct items. But permutations, remember, means that order matters. But combinations are just going to say, okay, we have a collection. So the order of these items, the order in which they were selected, doesn't matter. So this would be something like a poker hand or something like that. The order in which the cards were dealt to you doesn't matter. They're all in your hand. You can move them around in your hand. So yes, it doesn't matter. The way of writing this is NCK. So of N objects, choose K of them. That's one kind of nice way of thinking about that C instead of combination. Think about it like choose, N choose K. And again, we see these factorials showing up. Remember that N permute K was N factorial over N minus K factorial. And we see both of those pieces here, but we also see this extra K factorial in the denominator. Where is that coming from? Well, that's basically saying, hey, once you've selected your items and arranged them, well, the arranging part of that, once you have K items, right, you can arrange K distinct items in K factorial ways. So if we want to take away the arrangement, if we want to say, you know what, the arrangement of these things, the order doesn't matter, I just want those items specifically, then we can divide out this K factorial. So that's kind of where that's coming from in a quick version. There's a more expansive version of that definition in the book. So let's look at a couple examples though. So this one's going to be similar to one we saw for permutation. Suppose you have 16 books in a stack, but you only have space for 8 books on your bookshelf. In how many different ways can you select 8 books from the stack? So this is not how are we going to put them on the shelf and arrange them. This is just selecting those 8 books. So this is going to be out of our 16 books, we're going to choose 8 of them. So we could do the factorial version of this. We could say, well, this is n factorial on top, so 16, divided by k factorial, so that's 8 factorial, and then 16 minus 8 factorial, right? Or another way to say that is 16 factorial over 8 factorial, 8 factorial. So that's perfectly fine, and we know the Excel formula for figuring out factorial, so we could certainly do this, and we know how to divide and multiply. But probably if there was an Excel function for permutations, there's going to be one for combinations. So we'll take a look at that. But this is at least the setup here. So again, this is order doesn't matter. We're just collecting the books. So let's look at another example here. So in a casino game called Kino, a single drawing consists of selecting 20 numbers, 20 distinct numbers from the integers 1 through 80. Order of those doesn't matter, but again, they're going to be distinct numbers. So how many different drawings are possible? Well, again, because order doesn't matter, we have 80 numbers from which we want to choose 20. So we'd have 80 factorial over 20 factorial, and then 80 minus 20, so 60 factorial, right? These two numbers, the 20 and the 60, should add up to the number on top, 80. And that's before we factor in all of the factorials. So that's the idea there, but we're going to look at this in Excel. So I'm going to pull up the same sheet I was using before. So remember we had looked at permutations, that was just equals permute or permut, I suppose. And then we looked at factorials, which is just fact. And we looked at multiplying and doing exponents, kind of basic stuff. We went backwards there. So now we're going to do combinations. So equals comb, and we kind of see, anytime you start something off, you see a couple of options here. So we can, click on this to see what it's actually looking at, to see which one we want. In our case, we just want the first one. So it returns the number of combinations for a given number of items. So we say, okay, cool, that's the one I want. So number and number chosen. These were the same items that we saw for permutations. So we have, in the first example, we had 16 books. We wanted to select 8 of them. So this is just how many collections of 8 books we could get. remember that the number way up here, this was the arrangements of 8 books. And it really, sorry, it was the selection and arrangements of 8 books. So first we had to choose our 8 books out of the 16, kind of like what we did here. But then we went one step further and we said, okay, now I want to arrange those things. So more ways when we account for the arranging. All right, and then let's see. So then we have the Kino game. So Kino drawings, and we said we want to have a combination because it doesn't order. This is kind of like most lotteries, or yeah, basically like most lotteries where they have maybe all of the different numbered ping pong balls in a big bowl that's kind of getting blown around with air, and so they just pick them out one at a time. But again, order doesn't matter. So we're going to say of the 80 numbers, let's see how many ways there are to select 20 of those. And we see this huge number, right? 3.5 times 10 to the 18th. That is more than a billion, more than a trillion, more than a quadrillion. There are so many combinations here. So if you wanted to try to guess all 20 of those right, the likelihood of that happening is incredibly small because there are so many different possible drawings here. So 3.5 or 3.5353 times 10 to the 8th, so 10 to the 18th different drawings. So again, doing this in a calculator would have been really difficult and tedious, but doing this just using the combin formula here is much easier. You could also use factorials. So we had said in our first couple, we just wrote them, first in the combination notation, but then we said, okay, I'm going to use factorials. So for example, if I wanted to do this using 80 factorial, 20 factorial, 60 factorial, we could do that. Let's see if we get the same answer. So equals equals fact 80, right? So there's going to be 80 factorial divided by, now the only thing to be careful about is if I just kind of go through and I don't think about order of operations or how this is going to be interpreted, if I just said fact 20 times fact 60, right? If I just went through like that, we're going to get a different answer. So really we have to think about the fact the multiplication, the 20 factorial times the 60 factorial, all of that was happening in the denominator. So when we divide, we want to put some big parentheses around that product, and now we get the same answer. Another way to do that is just instead of using parentheses around that entire denominator, we could just say, okay, I'm dividing by 20 factorial and dividing by 60 factorial. And again, we get the same answer. So a lot of different ways to do it. Obviously, the fastest one is just to use that combinations formula or function in Excel.